All right, so let's now try to convert pressures to ATMs, because just like Kelvin always has to be, or the temperature always has to be Kelvin, pressure always, always, always has to be in ATMs. So let's imagine that the problem gives you 732 mmHgs. Well, that's not ATMs, so you have to get it into ATMs. So you're going to put 760 mmHgs on the bottom, and you're going to put 1 ATM on top. Why? Because that's what those things are equal to. 1 ATM is also equal to the height of the mercury, or height that the mercury goes in a eudiometer or in a barometer, and it goes up to the 760 mark. In that tube, it'll rise all the way up to the 760 millimeter mark. And that's equal to the pressure at sea level, 1 ATM. So anyways, if you do the math here, 732 times 1 ATM divided by 760, then you end up with about 0.963 ATMs. So then that's the number that you would plug into a problem. If you read a problem and it gives you a value in kPAs, kilopascals, then you say, I can't use that because it's in kilopascals, but I can convert it to ATMs because I know a conversion. 1 ATM is like the radio station, 101.3 kPAs. That's equal to 1 ATM. And if I do the math there, I get 1.758 or so ATMs. And then that's what I can plug into the pressure spot. All right, so now let's try this out. I read, and it says an 11.4 mole block of ice, so that's my N. A block of dry ice becomes a gas at room temp. Calculate the volume, so we need to know what the volume is. We don't know. That will be produced if the temperature of the room is 25. There's my temperature, and notice it's not in Kelvin. And the pressure is 743 millimeters mercury. So there's the pressure. And that's not in ATM. So we got some conversions to do here first. The first thing I want to do is take my temperature. As soon as I see it's not in Kelvin, I'm going to convert that. So this is 298 Kelvin. Then I can take that number and put it down here, 298. I see the 743 and I realize that's not ATMs, so I have to convert it. And I do it just like we did. Write down what you have. You have millimeters of mercury. Put 760 on the bottom. And then on top, you're going to put 1 ATM. And work that out. And you end up with about 0.978 ATM. So that goes in your pressure spot. 0.978 ATM. And then your volume is the unknown. It says calculate the volume. We don't know what it is. Put an X there. And then the number of moles is 11.4 because the problem tells us 11.4 mole block of dry ice. So 11.4 moles. And then our R, remember we never wonder what R is. We always know, 0.0821. 0.0821. Make sure you have that 0 in there. All right, so you work out the algebra here, and X, which is really the volume, comes out to about 285.2 liters. So now you know how much space that gas will take up if it's under these conditions. 0.978 ATMs, there's that much of it, and it's at 298 Kelvin. All right, last problem here in the notes. It says, what will the pressure in a tank be? So we don't know the pressure, so that's going to be my variable. We know it's a 10-liter tank, but we know it's going to have 101 grams. That's not moles, but you now know enough about grams and moles that you can look on your handy-dandy periodic table. 71 grams is equal to 1 mole. How do I know that? I looked in the chlorine box. I see 35.5, multiply it by 2 because there's 2 chlorines, and then I end up with a mole value of 1.42. That's what goes in the mole spot, not grams. R is always 0.0821. Temperature, 27 is not Kelvin. I've got to convert it to Kelvin, so that gives me 300 even. Gave you nice numbers to work with. So 300 Kelvin. I solve, I get pressure. X is my P. Do the algebra, see if you come up with about, when you round it, about 3.50 ATM. That's your pressure in atmospheres. The problem says give your answer in millimeters of mercury. So now we have to do the opposite of what we were doing before. We have ATMs, which is great, but for some reason this question wants us to give the answer in millimeters of mercury. So we're going to flip things around. 1 ATM. We put 1 ATM on the bottom because we want ATMs to cancel. We put 760 on top. And when you do out the math, you realize the pressure is about 2660 millimeters of mercury. So there's your final answer there. All right, you got lots of practice. There's a few pages in your packet where you get to practice these problems. I recommend labeling everything. Make sure temperature is always Kelvin. Kelvin goes in, Kelvin goes out. Make sure pressure is always ATM. ATMs go in, and any pressure you get out will be ATMs. You may have to do some converting like this to get the pressure in and out in ATMs. Volume should always be liters, N should always be moles. So if you read the problem and it gives you grams, you've got to do this conversion to get from grams to moles. All right, good luck.